Here's a problem on polynomials and a problem on rational functions. So here's the solution. How do I find the zeros of this polynomial? I want to find every place this is equal to 0. That means x squared is equal to 0. That means x equals 0. Or 2 minus x equals 0. So that's a solution. Here, let's add x to both sides. That means x equals 2. That's a solution. Or where does x squared plus x minus 7 equals 0? Well, remember, you can use any quadratic approach. So if I could factor that, that would be great. This right here, I think I'm going to have to use the quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 1 plus or minus, oops, I forgot my negative sign here. That's 1 plus 28, so the square root of 29 over 2. So there are 4 zeros to this polynomial. Now, as far as end behavior, first I need to know the degree, okay? The degree of this is 1, 2, 3, 4, 5. The lead coefficient is going to be what happens when you take all of those lead terms. So let's say x squared, the 2 won't matter so much. Negative x times x squared. The lead coefficient is actually going to be negative 1, right? So that's the lead coefficient, x to the 5th. So as x goes to infinity, if this is the term that really matters the most, as x goes to infinity, f of x is going to go to negative infinity because there's a negative lead coefficient. As x goes to negative infinity, as it goes the other direction, this is an odd degree, so this is going to go in the opposite direction. Odd degree, right? If you add an odd number of negatives, it will go a different direction. Okay, what about rational functions? Okay, the domain is every place that this function divides by 0. So where would that be? That would be 3x to the 3rd minus 2x squared factors as x squared times 3x minus 2. So where is that going to equal 0? It's going to equal 0 where x equals 2 and where 3x minus 2 equals 0. Did I say x equals 0? And 3x minus 2 equals 0. That means 3x equals 2 or x equals 2/3. Those are going to be both the holes in the domain and the vertical asymptotes. But as far as domain, we could say all x not equal to 0 or 2/3. Okay? Now for the range, we'll hold off just a moment. We'll think about what the function is going to look like. Let's think about the vertical asymptotes. The vertical asymptotes are going to be at x equals 0 and x equals 2/3. Okay. For the horizontal asymptotes, we're going to look at the degree of the numerator. The degree of the numerator is 2. The degree of the denominator is 3, right? Degree of the denominator is 3. So the bottom is going to be growing faster than the top. That means you have a horizontal asymptote at 0. If the numerator had a higher degree than the denominator, we would have no horizontal asymptotes. And if this was degree 3 and this was degree 3, it would be the ratio of the lead coefficients. So in this case, 1/3. But here we have a horizontal asymptote at y equals 0. So we have that. Now, this is going to be an interesting one because if you just had 1 over x squared, can you see your function would just be at the top? So we do have 2 vertical asymptotes, but it's really this vertical asymptote that's going to be the one that does interesting things. There's a vertical asymptote at x equals 0 that both shoots off the same direction. They both shoot off either positive or negative. But can you see this vertical asymptote right here at 2/3? It's going to be shooting off one direction here, and it's going to be shooting off the other direction here. And you can see there definitely are zeros to this polynomial. You could factor it. So the range is actually going to be all real numbers. Because you can see it's going to go as high as you want and as low as you want because of those vertical asymptotes.